teach you how to build a blockchain. What blockchain can do, understanding core capabilities. First, we need to delve into the core capabilities of blockchain to create meaningful use cases. Based on distributed ledger technology, developers can create a database environment for value exchange between multiple distrusting users and upload records without a centralized coordination mechanism. By combining the concepts of cryptography and game theory, the blockchain can achieve trustlessness in the system, ensuring that users can greatly reduce their dependence on third-party entities and conduct open and transparent interactions. Inside the blockchain system, the concept of decentralization is extremely important because it eliminates the negative effects of the failure of centralization, security vulnerabilities, network paralysis, and operational interruptions. In addition, as long as the security and activity are guaranteed, the blockchain network can prevent transaction review or other malicious behaviors by untrusted participants. Such distributed ledger systems have been successfully used in areas such as finance and dispute resolution. In the past, in these fields, all parties to a transaction need to submit their trust in a centralized authority, which will review and supervise the transaction data to ensure that the transaction strictly abides by the agreement. Companies like Hyperledger have created private blockchains for enterprise applications designed as decentralized transactional ecosystems to power the transactional operations of major technology, financial, and supply chain companies around the world. It's worth noting that these are outstanding blockchain projects and not among the 92% that are dead. As shown in this flowchart, for those looking for a blockchain solution, it is a checklist to do and an outline of steps to think through before committing to distributed ledger technology. The mortality rate of blockchain projects is as high as 92%. Here is the most reliable application building guide. Formulate application standards for blockchain cases. 1. Selection considerations for building a database. When we start trying to build a blockchain application when using a case, we need to study in depth whether we have a database that guarantees the basic security of all nodes. If the blockchain system we are trying to build is easily tampered with by the outside world, the project will lose its technical characteristics such as trustlessness and decentralization within the system, which will lead to many limitations in this application case. A similar example is the Blood Diamond Tracking Project. Provides services for companies to use blockchain to track legitimate diamonds in a supply chain from producer to consumer. Although the blockchain is a good solution for tracking diamond-related transaction processes, it still requires participants to submit a lot of trust to the employees and nodes within the blockchain system that put the diamonds on the chain. In this case, the nodes of the database cannot guarantee 100% security, resulting in the generation of trust issues that plague it. 2. Transaction parties. The next important question to ask before embarking on a blockchain is whether there are multiple parties involved in taking action in the database. If the database does not require the coordination of many stakeholders and can be functioned by a key primary author, then a centralized database should be considered. In terms of innate attributes, the essence of blockchain is distributed ledger technology, but if there is no need for decentralization of database ownership, we should enable different database structures. From this point of view, in simple terms, in the process of building a high-quality blockchain application case, it is often overlooked and forgotten. In fact, compared with the existing decentralized blockchain system, centralized software such as Oracle Database or MySQL can create a more robust transaction underlying structure, which means that we should only use distributed ledger technology. A more obvious example of the centralization trend is that existing technology giants such as Facebook or Google use exabytes, a storage unit with a large capacity, to manage user data. While it would be nice for Google to decentralize the transaction process for users, such a blockchain application would be moot. This is because in a centralized system, all information passes through a single node, making it easier to track information. In terms of basic nature, compared with decentralized systems and distributed ledger technology, centralized systems are more internally integrated and consistent, and can better achieve economic scale. In fact, it seems that Google products like Gmail are able to achieve intelligent spam filtering because Google can easily snoop on almost everyone's email. 3. Trust. After deciding whether a centralized setup is important for a blockchain use case, it is critical to understand what we need to commit to trust, both in terms of system performance and the consequences of a lack of trust. In a centralized system, the actions of malicious attacks will take different forms. A centralized authoritative organization not only tries to edit and modify existing transactions, but also conceals information, and even submits reports of abnormal transactions in the entire network environment to supervise users who implement specific transactions. If, due to some stimulating factors, the centralized institutions have taken the above actions in the existing system, we should consider adopting security measures such as introducing blockchain in the application case. But if the need to submit trust is not an obvious issue among users, then in a blockchain project, we can simply use a distributed database in which users also hold a copy of the data, and can upload information or update the state of the database at any time. If there is no need for blockchain security measures such as Byzantine fault tolerance, such a setup will be more easily exploited. Special case analysis, public chain and blockchain requiring authorization, consortium chain. It is also worth noting that applying a blockchain system benefits from the collection of concepts in centralized databases, distributed databases, and distributed ledger technology. Blockchains that require authorization, such as alliance chains, are the embodiment of such a collection of concepts, combining a centralized user authorization mechanism with a decentralized blockchain transaction ecosystem. Such a blockchain has the authority to allow users to enter the network, making it possible to reduce malicious attacks. At the same time, it can also create a blockchain system that is different from traditional public chains. It does not require too many fault-tolerant mechanisms and reflects more safe performance. The disadvantage of such a blockchain structure is that, compared with the public chain, its degree of trustlessness is lower, and users still need to submit trust to this organization and the consensus mechanism applied to the whole system. JP Morgan's Quorum is one such blockchain use case that requires authorization. Among them, the company empowers the financial industry with high-speed transaction performance, dozens to hundreds of transactions per second, by reducing the use of Byzantine fault-tolerant algorithms. 4. Disintermediation. Another important consideration is that developers need to decide whether disintermediation is necessary in the transaction system. If the blockchain solution is to solve the excessive intermediary fees and the time delay caused by confirming transactions, blockchain technology can speed up the optimization process and reduce the overhead of all users in this regard. However, if disintermediation is not essential for the entire transaction system, then assigning the task of verifying transactions to an intermediary or a centralized institution will greatly reduce technical difficulty, because there is no need to deploy distributed transactions on the blockchain network. Validator. 5. Mechanism design based on transaction interdependence. Before starting to apply this blockchain application case, we need to think about the last question, whether the transactions in the system are generated by interdependence. This characteristic of transaction dependence can be found in all types of database systems, especially in a multi-user system involving multiple parties or involving the exchange of assets and commodities, such as retail. If each transaction has no interactive relationship with each other, it will greatly improve efficiency to apply a master-slave database structure, where the master node verifies or approves a certain subset of transactions, and the slave nodes are responsible for performing the work. But if transactions do exhibit an interdependent nature, distributing transactions among major nodes will become quite difficult, in which case blockchain is the solution to changing such a centralized database. In addition, the blockchain can also provide atomic performance, the ability to be consistent within the database, for the user's transaction process, ensuring that interdependent transactions can be executed immediately without being cancelled or tampered with during the transaction happening. This also ensures that in such a complex transaction structure, no wealth will be created or destroyed out of thin air,